Hello, everyone. So today we're going to be finishing up our discussion of how to write a scientific paper by focusing in on the real meat and heart of the topic, how to write a results and discussion section. So one of the things I want to make note of is that in reality, these are often going to be presented as separate sections and have very different goals. But traditionally, you're really going to want to write these together because what we're going to be focusing in on is a combination of how to present your results and what you actually found. But just as important um, is um, what these results actually mean. So while the results is going to be focusing on what did you find, the discussion is going to be what do they mean. And one without the other isn't exactly that helpful. So it's very important that even if you do write these two sections separately, that you're always thinking about the other section or the other question when you're say writing one. So whenever you're writing results, always think about what do these results mean? And whenever you're writing the discussion, always think about what these results are. And as long as you keep these two goals in mind, it should help present a good general story. And one of the other things that's important to remember is that humans aren't exactly trained to be able to understand a long list of facts. We're trained to think in terms of narratives. So, one of the important things to do is to try and combine these two things into a cohesive narrative. Now, sometimes, especially if you have multi-part results, it can be helpful to put all of your results together and all of your discussions together. However, in order to essentially not lose track of what your results were when you're talking about the discussion, it can be very useful to say, present one result and then discuss its meaning, present a second result and discuss its meaning. And we're going to be focusing in more on this method while writing papers for this class. So one of the things that is worth keeping in mind is what do we do if we have multiple results? So let's say I've got three major results I need to present. Say I may have a separation, a an analysis, and a synthesis. So in order to discuss these three separate results, I can do one of two formats. The first is the classic traditional format of a blocked format. So I put all of my results together, result one, result two, result three. So this is everything I found. And then I'll go ahead and I'll walk through these results, talking about them one after another. And again, if you have data where result two is highly dependent on result one, this is often a good way to let the narrative flow. However, sometimes it's going to be easy to lose track of what result one was by the time you discuss it. So one of my personal favorite formats is what's called the iterative format. So I present my first result and then I discuss it. I present my second result and then I discuss that. And then the third result and discuss it. So one of the things I want to make note of is that in most of my rubrics, I'm going to be grading the results and the discussion separately. However, that doesn't mean that they should always be written separately. So whenever you are writing a results and discussion section, think about which narrative flow is going to best fit your data. So let's go ahead and focus a little bit more on this results first, and then we'll address the discussion later. So if I'm going to go ahead and present my results, I have to be careful about kind of what order I present them in to essentially keep a good narrative flow and make the progression fairly logical. So one of the first things you should do when presenting your results, and this one's often easy to forget, is to set the stage. So before I say start throwing results at you, I need to give some context. So the methods section may have been a long time ago, or it may be at the end of the paper. So always start with a quick reminder of how you obtained the results. This is often no more than a single sentence of saying, a spectra of sample A was collected via UV vis analysis. And that's usually enough to just remind Remind the reader of exactly what you're talking about so nothing comes out of left field. However, let's say I'm talking about, say, spectrum A. Well, the reader may actually want to know where that spectrum is located. So again, combined with this setting the stage is going to be directing the reader to any graphics. So again, these two things can often be accomplished with a single sentence. However, with more complicated results, you may need a little bit longer. But again, try and keep it concise to avoid the reader getting lost. So now that you have so now that the reader knows what you're going to be talking about, then it's important to kind of move on to telling the story of scientific discovery. So again, try and make sure that this follows some sort of narrative bend to essentially help guide the reader through what you're talking about. But while doing this, make sure you hit a couple key points. First of all, make sure you identify any key findings. So let's say I'm referencing, say, a large spectra. Well, what sort of things should the reader be trying to take away from the spectra? Am I emphasizing, say, peak height? Am I looking at lambda max? So again, what should the reader identify that's important about the spectra? What does it tell me? And essentially, any key things that you want to direct the reader's eye to, especially if you have large spectra tables or uh, large graphs, a series of spectra, or just some complicated, messy results. Help try and direct the reader's eye to what really matters. And again, part of this is if there's not, say, a single result, but more important trends, try and emphasize these as well. And this can often take a lot of wrestling with the data to make sure that you've identified any important trends that might be important to take away from the data. And again, one of the most important things is if the reader looks at a graph or a table and something kind of stands out, you should make sure that you've already highlighted it and explained what these sort of unexpected results are. And sometimes this is a good unexpected result of, ooh, this big peak or this anomaly, this is what we were looking for. And sometimes it's simply saying, oh, that big messy peak in the middle of my NMR, yeah, that's water. So again, whether it's good or for ill, make sure you highlight any unexpected results, as the reader is going to always wonder what they are, whether you address them or not. And again, let's say I'm doing this, I have 3 separate results I need to discuss. You can go ahead and repeat this process for each of your results, whether it's in the block format or iteratively. However, if I've gone ahead and discussed my results, presented my results, I also need to discuss them. So this section can take slightly different formats, whether I'm looking at a blocked or an iterative format. So if I'm, say, working in a blocked or iterative format, the first thing I'm going to want to focus in on is specific results. So if I'm working in a block format, the first thing you need to do is remind the reader which results you're talking about. If I have 3 different results and I spontaneously say, oh, this peak means what? Well, which peak are you talking about? So again, one of the dangers of the block format is the ease of losing track. So make sure you always start off your discussions being very specific about what results you're talking about, and occasionally a good reminder of where they came from, just to, again, present context. But whether you're working in an iterative or block format, you're going to then start working on an interpretation of your results. So again, what you're going to want to do is elaborate more on what the meaning of these results are. And then this is perhaps one of the most important parts of really physical chemistry, is physical chemistry is always interested with the why. So make sure you give possible explanations for why certain results may be present. And again, the proposal of explanations is one of the most important parts of your discussion section. But in order to essentially propose an explanation, you're going to need to support that. So if you have a rather exceptional explanation, make sure you point the reader to any literature that might go ahead and support this. If you're using, say, more basic principles that may be found in a physical chemistry textbook, this might be considered as simple common knowledge, and an explicit reference might not be necessary. But if you're in doubt of whether a reference should be made or not, always always side on the uh, always side with caution, and make sure to provide a reference if you're unsure. Now, again, one of the things that's worth noting is that since I'm discussing each of my specific results with their specific interpretation and explanation, this is going to need to be repeated for each of my possible results. And again, one of the things to watch out is, again, if you're in a blocked format, make sure that each time you're just talking about a new section of your results, you start with a quick reminder of what those results were. However, once you've discussed each of your specific results, you're going to want to move into essentially a second part or section of your discussion. And that's going to be essentially kind of concluding the paper and wrapping everything all together. So here you're going to want to go ahead and summarize your work. And this can often be in the context of once you've presented an explanation for each of the individual results, you can start talking about how they kind of work together and compare and contrast. And from there, you can kind of move on into overall implications. And it's one of the things that's worth noting is that for many papers, this is kind of given its own section as either the conclusions or the summary section. But if your discussion is typically much longer than a paragraph, or if this conclusion of your paper of comparing your results is more than a paragraph or two, it's typically considered as part of the discussion, and the last more focused summary will be given its own section of conclusions or summary. Now, when you're working through these conclusions, there's a couple of key questions you're almost always going to answer, almost always going to want to answer. And the first of all is, what are the wider implications for the work? What does this work mean? Why is it significant? And as part of that is kind of specifically what new insights or pieces of information were gained. Anything unexpected, or honestly, least interestingly, everything is as expected, at which point then you might wonder why you did the paper. And again, part of this is going to be looking at what specific increases in our understanding have we developed. So is there any specific piece of information that, while it might not be unexpected, may be important, whether it's, and this can be something as simple as developing a new parameter for an important set of equations that might be necessary for, say, modeling the behavior of a gas in an industrial process. That's still important knowledge to try and gain. And this essentially can often be combined with this idea of practical applications. Because while general and fundamental knowledge is often important, practical applications is usually what funds most work. So how can I put this knowledge to use? And then in the more higher-minded goal, how can this work impact society? So this is often very important when dealing with things such as green chemistry or developing new products that can actually help society as a whole, and maybe not just a specific field of science or industry industry. And again, one of the biggest things that's important about this last summary and conclusions is to try and zoom out and look at the whole work together. Try and identify any sort of unifying themes. And most importantly, if you presented some wider implications of why this work was important in the introduction section, you should always tie it back in your conclusions. So if you present, say, that designing a new organic catalyst is important to, say, produce to produce biodiesels, then you're going to want to bring that same idea back in the discussions. Otherwise, it's just a hanging thread. And one of the most important things is as you finish your conclusions to tie any of those loose threads together. So if you raise a question somewhere else, it should almost always be answered in the end of the discussions or the conclusion section. So that brings us to the end of our how to write our paper. So hopefully that brings most of your major questions to conclusions. So good luck writing and take care.